Hi guys, welcome back to my video, and for today's discussion I am going to discuss to you about discrete probability distribution. Okay, so a discrete probability distribution, this is a list of probabilities associated with each of its possible values. So we're dealing here with a random variable. So I have already explained from my previous video what is random variables and what are the classifications of random variables. So if you missed the lecture, so please have a quick visit on that video. Okay, so here I have my first example. We have let x be the number of head after tossing the coin 3 times. Okay, so let's try to answer that first problem. So we knew that if we toss a coin 3 times, we have 8 possible combinations. Okay, so let's make a tree diagram so that we can enumerate the possible combinations. Let's try to solve it or tail. Then we have tail. We have head, tail. The other one we have head or tail, head, tail, and head and tail. So the combinations are H, H, head, head and tail, head, tail, head. Also have head, tail, 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 head, head, tail, head, tail, tail. How many combinations we have? We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 combinations, and these are the possible combinations. Now, if we do the experiment, so in here, I have already discussed from my previous video that we have a random variable here. We have our random variable Rx, R0, 1, 2, and 3. So meron tayong 0 since um, we have possible combination na walang head na lalabas in our experiment. Now that is all tail. Okay. Then we have 1, random variable 1, since we have a combination that contain one head. No, that is HTT. This one we HTT. We have THT, and we have TTH. Okay, and we have two random variables since we have combination that has a two heads. We have this HHT, we have HTH, and we have THH. And we have also three since we have a random variable, or we have combination that all combination or all outcomes will be head. That is head, head, head. Let's say this is our, okay. So that is our random variable. So let's make a probability distribution to this. So we have for probability, now we have x is equal to 0. That is since how many combination that contain or that consist no head, we have only one. Okay, that is a tail. So we have 1 out of 8 combinations. So this is our probability distribution for x equal to 0. And probability distribution when x is equal to 1. So how many combinations that consist or that contain one head only? We have HTT, we have THT, and we have TTH. Therefore, we have 3 out of 8, correct? We have also probability when our x is equal to 2. Then we have combination x equal to 2, or we have two heads in the experiment. That is 3. We have HHT, HTH, and THH. We have 3 over 8 probability. And lastly, we have probability when our head is equal to 3. That is, we only have one combination out of 8, no? That would come out all heads. Okay, so these are probability distribution. So let's try to draw it in the, let's try to plot it in histogram, in a histogram. So we have histogram. Okay, so we have y, or this is our probability, and this is our outcomes. Okay, so this is our probability, and this is our number of outcomes. So our probability, the maximum value is 1, correct? So let's divide it by 8, since this is our 1 over 8, this is our 2 over 8, and this is our 3 over 8. So let's try to plot, and the x-axis is the number of outcomes. We have 0, 1, 2, and 3. So let's try to plot it in our histogram. So we have 0, the probability when our x is equal to 0, or when our head is equal to 0, it is 1 over 8. So this is 1 over 8. So most probably this one here. Okay, so this is our distribution. Okay, 1 over 8. And when our x, or when our head is equal to 1, our probability is 3 over 8. So we have 3 over 8 here. And we also have, when our x equals to 2, we also have 3 over 8 probability. Okay. And when our x equals to 3, we have 1 over 8 probability. Okay. So this is our histogram. The next one we have make a, or compute the probability distribution of the sum of two dice, or let x our random variable of the sum of two dice. Okay, so in this case we have how many random variable? So we have sum. So our sum would be, the minimum value is 2. We have 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. The minimum sum would be 2, which is, this is one combination of 1, 1, and 12, which is the combination of 6, 6. So this would be our random variable. Okay, so after that, make a, or compute the probability of the each random variable. We have our probability, but a probability of x is equal to 2. That is, we have only one combination that could be equal to 2, that is on 1, 1. Okay, we have 1 out of 36. Okay, or that is equivalent to 0.028. We have probability of x is equal to 3. That is, we have 3 here, that is 2, 1, and we have other one, we have 2, 1, or 1, 2. So we have 2 out of 36 probability distribution, that is 0.056. Then we also have probability distribution when x is equal to 4. The sum is 4. So what are these combination? So we have 4, that is 1, 3. We have 2, 2, and we have 3, 1. So therefore we have 3 out of 36. That is equivalent to 0.083. 0.083. Then we have probability distribution when our x is equal to 5. So we have for 5, we have 3, 2, 2, 3, and we have 4, 1. Correct? So therefore, we have 3 over 36, that is equivalent to 0.08, sorry, say 3. Then when our probability is x is equal to 6, that is equal, the combinations are combination 5, 1, 2, 4, 3, 3, 4, 2, and 1, 5. So we have 5 out of 36. That is equal to 5 divided by 36. That is equal to 0.139. Okay, then we have also our probability is 7. So what are the possible outcomes when our sum is equal to 7? The combinations are 6, 1, 2, 5, 4, 3, 3, 4, 5, 2, and 1, 6. So there are 6. No? Our x equal to 7. This is equal to 6 over 36, or equal to what? By 36. It's 0.17. 8.17. Okay, now we have when our probability is the sum is 8. No, so we have if 8, the possible combinations are 2, 6, 5, 3, 4, 4, 3, 5, and 6, 2. That is equivalent to 5 over 6. So this is 5 over 36 equal to 8. Then when our probability, when the sum is equal to 9, that is 6, 3, 5, 4, 4, 5, and 3, 6. That is there are 4. Okay, so 4 possible value. Okay, so therefore that is when, sorry, I computed it wrong. No, it should be in 4. Okay. So 4, that is equivalent to 0.11. This is also the probability for our sum is equal to 9. Now for our probability when the sum is equal to 10, so we have 3 possible combination. We have 6, 4, 5, 5, and 4, 6. So we have probability the same as with x is equal to 4. And so on, this is probability that x is equal to. Okay, so these are the probability distribution when our x represents the sum of two dice. Okay, so now let's try to create a histogram. Okay, let's create a histogram that is the y-axis the probability and the x-axis is the random variable. Okay, this is our random variable or the sum, and this is the probability. Okay, so in order to consolidate or to minimize the space now in our graph, so let's try to get our maximum probability here as point, let's say it is 0.2. Okay, and this is our 0.1. This is our 0 or coordinates. Okay, let's try to plot these in a histogram. So we have here we have our random variable, which is 2. We have 3. We have 4. We have 5. We have 6. We have 7. We have 8. We have 9, 10, 11, and 12. So this is our random variable. So let's try to plot it in a histogram. Okay, so in histogram we have for our x equals to 2, therefore we have 0.028. So probably dito siya. Okay, okay, then for x equal to 3 we have 0.056, or that's half. Okay, half, so more than half. So this is the 0.056. Now when x equal to 4, that is 0.083. 0.083, this one here. When our x equal to 5, that is 0.11. 0.11, so this portion here, this portion. Then when our x equal to 6, that is 0.139. 0.139. Okay, then when our x equal to 7, it is 0.17, so almost 2. This is our 7. Okay, now when x equals to 8, that is the same as with x equal to 6, so it is symmetrical, correct? So symmetrical for same as with x equal to 9. For x equal to 10, the same as with x equal to 4. So kamo na like kuan when our x equal to 11, that is the same as with x equal to 2, that's 0.056. This one here. And for 12, that is only 136, that is this portion here. Okay, so this is the histogram, no, of the sum of two dice. So that is the probability distribution of the sum of two dice. And then lastly, okay guys, I have here a new example. A shipment of 20 similar laptop computers to a retail outlet contains 3 that are defective. And if a school makes a random purchase of 2 of this computer, find the probability distribution for the number of defective. Okay? So if we pick 2 of these laptop computers, so what would be our random variable? Okay, so our random variable would be x equal to, there would be no defect, no, na makukuha natin in the out of those 20 laptop. So there's a chance na hindi tayo makakuha ng defective laptop. However, there is a one chance, no, na makakuha tayo ng defect out of the 20. And lastly, pwede lahat ng makuha nating dalawang laptop are defective. Okay, so our random variable are 0, 1, and 2. Okay, so make a probability distribution. Okay, how to make a probability distribution to this? Okay, so we have the probability for x is equal to 0 would be how to compute for the probability. As a review, since we are just going to select from these 20 computers, so what are we going to use here is combination. Okay, hindi tayo gagamit ng permutation. Combination yung gagamit natin because it doesn't matter hindi magmamatter yung order ng pagka-select natin ng defective ba or hindi defect. Okay, when x equal to 0, so what would be the total combination? The total, since our probability diba is the total combination. The combination of the event over the total possible combination. In this, the total possible combination would be what? We can get 20, we can get 2 out of this 20 laptop. Okay, that is 20 combination of 2. Okay, the total combination. Now, what is the number of combination na walang makukuha tayong laptop? So, we can say that, di ba, we have 20 laptops and 3 of these laptops are defective. Therefore, we only have 17 laptops that which are in good condition. Okay, which are in good condition. So therefore, we only have 17 laptops that are good in condition. So we can therefore, our probability or our chances or the number of combination na makukuha nating laptop are in good condition, that is 17 combination. Okay? So therefore, this is 17 combination of 2 divided by the 20 combination of 2, that is equal to 68 over 95. Okay? That is 68 over 95 ang probability na lahat ng makuha nating laptop or ang makuha nating dalawang laptop are in good condition. Okay, next we have for random variable x is equal to 1. In this case, isa lang yung makukuha natin na in good condition. Okay? So, out of 3, ang makukuha natin na bad condition is 1. Right? That is 3 combination of 1. Then multiply it. Out of 17 laptops na in good condition, ilan yung makukuha natin? We can only get 1, right? That is 17 combination of 1. Okay, that is over. So the total combination is 20 combination of 2. That is equivalent to, that is 51 over 190. Now the next we have when our random variable is 2 or the combination or ang makukuha nating laptop are all defective. Correct? So out of the 3 defective, we can select 2. Correct? Now in 17, ilan yung makukuha natin? 0, since lahat ay defective. Wala tayong makukuhang laptop na in good condition. Over the total possible combination is 20 combination of 2. That is equal to 3 over 190. Okay, so this is the probability distribution. No, we have in our x is equal to 0, 1, and 2. Therefore, our probability x is, so this is the probability distribution.